Hello, everyone. Today we will delve into Section 2, Symmetric Cryptography. The classification of cryptographic algorithms is mainly based on the following criteria. 1. By the characteristics of the key. We can divide them into symmetric cryptographic algorithms and asymmetric cryptographic algorithms. 2. By the way plaintext is processed. We can divide them into stream ciphers and block ciphers. Let's first explore stream ciphers. In stream ciphers, both encryption and decryption processes use the same pseudo-random cipher digit stream, key stream, as the key. Each plaintext digit is encrypted one at a time with the corresponding digit of the key stream to give a digit of the ciphertext stream. The pseudo-random key stream is generated from a random seed using a PRG algorithm. It is important to emphasize that the PKG must be unpredictable. Now, let's examine block ciphers. Block ciphers work by dividing the plaintext into several fixed-length blocks and using a predetermined algorithm and symmetric key to encrypt or decrypt each block. The formal representation involves dividing the plaintext message sequence x0 to xj into several blocks x of fixed length p, where each block is encrypted or decrypted with the key k, the key set k0 to kt-1, to produce ciphertext blocks y of length m. The principles of block cipher design are as follows. 1. Diffusion. Each bit change in the plaintext should influence as many bits of the ciphertext as possible in order to obscure the statistical properties of the plaintext. Additionally, each bit change in the key should rapidly diffuse to affect as many bits of the ciphertext as possible in order to obscure the statistical properties of the key. 2. Confusion. The relationship between plaintext, key, and ciphertext should be as complex as possible during encryption and decryption processes. Even if an opponent obtains some statistical properties of the ciphertext, they would not be able to deduce the key. Based on these two principles, the product cipher is a combination transformation of both confusion and diffusion operations, and it can achieve good diffusion and confusion effects. Next, let's study the process of symmetric encryption. First, the plaintext information is transformed into ciphertext using a key and an encryption algorithm. After passing through a public channel, it reaches the receiver, who uses the decryption key and algorithm to recover the original plaintext. In this process, the algorithm does not need to be kept secret. Only the key needs to be kept confidential. Next, let's analyze the symmetric cipher model. Its advantages include 1. Convenient key memorization. 2. Low computational overhead. The algorithm is simple and encryption is fast. Its disadvantages include 1. Key exchange security and efficiency issues. 2. Key management complexity. Since it uses symmetric keys, proper and secure management of the key is crucial. If the key is lost, the cryptosystem is compromised. 3. Limited to data confidentiality. It cannot be used for digital signatures, nor does it offer non-repudiation. Common symmetric key algorithms include 1. DES, Data Encryption Standard, a scheme originating from IBM. 2. Triple DES, also known as the Triple Data Encryption Algorithm. 3. AES, Advanced Encryption Standard, a block encryption standard adopted by the U.S. federal government to replace DES. 4. IDEA, International Data Encryption Algorithm developed from the DES algorithm. IDEA is a block cipher with a 128-bit key. 5. Blowfish, a cipher with key sizes ranging from 32 to 448 bits. 6. RC2, a proposed alternative to DES, with 64-bit input and output. 7. RC4, a stream cipher with a variable key length. 8. RC5, a parameterizable block cipher algorithm where the parameters include block size, key size, and the number of encryption rounds. In the RC5 algorithm, 3 operations are used: XOR, exclusive OR, addition, and bit rotation. Next, let's delve into the DES algorithm. DES is the first and most important modern block cipher algorithm. Its main principle is to use a 56-bit key to encrypt 64-bit data. The main encryption process includes 2 permutations and 16 rounds of iterative encryption. Let's take a look at the specific process. After inputting the plaintext, it is first permuted into 64-bit blocks. These blocks undergo an initial permutation, IP, and then a series of hierarchical transformations, which involve 16 rounds of iteration. After the final iteration, the data is subjected to an inverse initial permutation at the receiving end to produce the 64-bit ciphertext, which is then output. So, at its core, DES still uses the 56-bit key to encrypt 64-bit plaintext. That concludes our discussion on Section 2.